We will wait a couple of minutes before. Are you able to see my screen?
Yes.
Are you able to see my screen?
Yes, Professor.
Okay, let's start. So, are there any questions from the last class? We have had quite a long gap. Any questions you want to know? Anything which you feel there is some gaps? Yes, anybody, anything?
Yeah, Professor, I tried, but the quadratic function, all that little not able to get it the answers. So didn't much actually time to do the practice.
No, please practice, because the only thing is like how you have to implement, and in Excel you also have the book which I have given. Pick up some examples and try to do it. So it will go a long way. And I mean to say, in a book also you write down like what you are able to implement, the way and all tips kind of a thing and all. Please note down in your books so that it will be good. Otherwise, if you don't put it on paper, it will always say that everything is there in our thought process, so we are not able to translate it later. That's the challenge which we all face.
Professor, we have a one subject that is research methodology. Is it the same statistics are using? Because we can see the probability statistics, all the concept there.
You are very much right. That's there, same thing only. Thing is like you understand whatever is there as part of research methodology. I mean to say, like how people look for any problems in a process or something like that, how to solve it, the ways to solve it, what's the setting up and hypothesis. So all this conceptual data aspects and all are taught as part of the research methodology. Here, whatever the hypothesis which you state and all, I will show you through calculations like in statistics, using one or two examples like how you have to solve it. But the theoretical aspects is something like that management research methodology one has to understand, because that's a process by itself. So any company, if you are working at all, will have certain processes and all. So the way which we follow for learning this management problem solving and all is the research methodology. So it's not that we follow step by step kind of thing. From academic standpoint, we will understand the thing. But going further, as you go on getting practice and all, so things will become trivial, and you'll have some kind of a templatized way to solve. That's the way which you have to do it.
Okay, thanks, Professor.
See, like this, I also have a white unruled book. Any point and all which I have to make, I will try to make it. So even today, this has been a practice for past 30 years. I don't know how many set of books I have all on my attic. So everything is there. Probably after a year or 2 years and all, I do refer some things. Probably I can refer it. So make it a point, like whatever you do and all, please note down things, because don't put everything on systems. So it may help. I don't say that thing, but no, putting it on a paper might be of much help. Okay. So I have posted one link here. Let me share the link to you also. Chat. Yeah, please click on this thing and open on your laptops also. So see, these are, I think, in the first class and all, I was mentioning that I'm very fanciful of. I read a lot, in fact, and that's my this thing. And politics also makes me very much interested. Even then, seeing a TV, the social media and all, I love to read it. Of course, apart from my newspaper, some things like which interest me and all, which I have subscribed to and all, I do it. So why I brought up this thing is like how you have to solve, if you solve a problem and all, how to come up with a report. See, these are all academically good, and if you are really somebody asks for a very detailed scientific report and all, this is the way which you should interpret. So somebody has done some analysis of the impact of sanctions on the Russian economy in India. So you know that Russia-Ukraine war is going and all. So somebody using data has tried to analyze it. So these are some things which will be helpful either ways, like how you are see for this thing and all. There is a background from where the author, Mr. Deepanshu Mohan, have taken it, and he has said, and it might be his perspective, he might be biased. Everything is fine here, but you will understand it from an objective perspective, like how charts really help, how data really helps us to solve things, and or if you are doing any research projects and all, how we have to frame problem, how we have to look into the way, like you have to understand between lines and all. So that you have to keep it in mind. So please see this thing. You can also go through it leisurely. So it's a very good thing. Like people have done a lot of graphs here. So he has compared Russian currency to US dollar. So it's a way, it's one's own creative ability, ingenuity, critical thinking, the way which you see it and all can be done. So lots and lots of graphs can be explored. See, this is also analytics. Even though you do all that fancy data science, machine learning, algorithms and all, at the end of the day, presentation is this much only, nothing else. People understand this much as far as the presentation goes. Only highly on both sides of the client and the people who are trying to solve it and all are highly grammatically aware or mathematically aware at all, they will understand some of the nuances between algorithms. But when you present it, so this is the kind of a thing which is expected of somebody. You are given a data, you have to answer it. You have to see this thing, problem statement and answer. So that's what I wanted to show. Rate of inflation. So central bank rate of interest. Source will be there. You have to give the source. Consumer confidence level. So either this might be from a what you call survey, he might have done it, or he might have borrowed this data from somebody else's surveys and all. So that's also possible. Current account, fiscal expenditure, government debt to GDP ratio, and there are some small tables. There are summary tables. So what we saw in a pivot chart and all. So this is how it has to be put it here. End of the day, they'll state the thing, hypothesize something, solve the problem, and they give their own way of interpretation. So it's a very lengthy article, of course, more academically inclined. But yes, so if you people do follow Economic Times, Economist, and all, these are the kind of things. Yep. Or even in business journals and all, this is how it has to be written. So I wanted to emphasize on the way data analysis is done in real life and how we have to analyze it and how we have to present it. And it is not that we write 2 lines, 3 lines, and we have to really get in depth into the thing in answer. Each one of them, probably I give you an assignment. If you have to solve it, you have to get deeper into this kind of a thing, solve it, and come up with. I would be expecting your insights into this thing. So that is important here. So insights means how you slice the data. It's left to you. There are many ways which you can slice the data. You can hypothesize the way which you want it. So that is expected of a person behind this thing. How we need to do a data analysis. Okay. So do look into this thing. This is one of the things because whatever comes to my this thing, I usually present in classes. So this was very interesting. So I think day or 2 days before, I think I was reading this thing. I thought this will be of importance, so that I have presented here. So let's get back to our random variables. So we had a huge session on this thing, probability. If you remember, so we had talked about experiment, event, sample space, how to attach probability, how to calculate probability. Of course, like given some problem thing. So toss of a coin, choosing something from a set of marbles or something like that, or candies or something like that. So roll of a dice, playing cards. So these are some kind. These are all common examples. Probability is thought. So all tend towards gambling. So, but nevertheless, people do understand it. It's the best. So moving further, so now we move from something like where there is a measurement of probability. So we have a variable interest. So variable can be anything. So it can be some height, weight, so currency, stock market prices, our own BP, sugar readings. Anything is random. So that's what which we try to learn. So solely from probability, we connect the dots to random variables. When I have random variables, we move to statistics. That is the bridge or the pipeline which we follow. So quantitative variable X, the random variable, if the value that it assumes corresponding to the outcome of an experiment is a chance or random event. So in this thing, you have found out experiment, chance, random, and event. So all these things we studied in silos. So all things are connected now. So when I say variable on a spreadsheet in Microsoft Excel, a column of data where you record your measurements, that can be called a variable. So computer science or a database people call it as a field. Statisticians call it as a variable. Computer science or people from the artificial intelligence call it as an attribute. So these are the various ways. So intermittently it will be used like somebody says this thing. So don't get confused. To your mind, what it should be there is it's a column of data. So top to down, vertical, usually vertical only. Nothing in horizontal also you can put it. Not a problem, but generally accepted role is should be in the vertical format, and that's the way a random variable will be there. So whatever we add everything there, putting everything together, we have now a random variable. So random variables can be discrete or continuous. So example here, SAT score or GATE score for a randomly selected student. So X can be number of people in a room at randomly selected time of a day. So X number of the upper face of a randomly tossed die. So anything can be a random variable. It is discrete, for example. So then I come to a column of data is a distribution, what we call it. So it's distributed. Distributed means you have a set of points, all columns together. So we call that as a distribution of data. So single is a scalar quantity. So whatever we calculated in last classes is all scalar in quantity. So a column of data is a random variable. If it is discrete, then we have put things in a format that's as a discrete random variable. So probability distribution for a discrete random variable x is a graph, table, or formula that gives the possible values of x and the probability of px denoted by px associated with each value. So we must have p of x. So as I told you, probability values will be between 0 and 1, and summation of px will be 1. So that we saw in our other examples also. So we have something here. So it's a discrete kind of example. Toss a fair coin only 3 times. So x is number of x. So I get 3 coins I toss. So 3 HHH, that is 1 by 8. HHT 1 by 8. HTH 1 by 8. THH. So I have got 8 times the 3 coins are tossed by 3 people. So that also let us put it there. The first is like x is how much number of times heads are there. So the probability associated with this 1 by 8. So probability x is 0 means it is a discrete event. So x is 0 means the last one. So that is 1 by 8. Probability of x is 1. So for each one, 1 by 8 is the thing. So you multiply that probability. What is the chance of that thing where I get 2 heads? When 3 people toss a fair coin, that's what we say. So I think if you know, like during the start of a match, people toss a coin. So the person who is going to touch the coin will say that it's a fair coin. I mean to say there's no discrepancy in that coin. So we say it is a fair coin. So x is equal to 1, that is 3 times 3 by 8, 2 times 3 by 8, x is equal to 3, 1 by 8. So that's the first event just happened. So what are my discrete values? 0 to 3 we have. And what is the probability associated with it? It is 1 by 8, 3 by 8, 3 by 8, and 1 by 8. What are the chances I get 1 is something like, so it's a complete like all the permutation, because we did some permutation combinations also. Everything was taken into consideration for this thing. So we attach a probability to it. So we get this probability. So what we are doing very discreetly or in silos or something like that, I attached a name as random variable. So everything got mixed like an experiment, event, sample space, everything and all. So with this thing, so with an example, if I have to say, I again toss a coin, I get what are the values which are discrete in nature, what is the probability associated. So anything which you do, it can be any production example also, anything in stock market, anything with regard to healthcare and all, everything will have a probability attached. So even though you may not see that thing like you have an x and p of x and all, whatever it is there, when we get some x, so it has some probability attached to it. So it's an assumption. So it's a mathematical assumption we make, but is an example to correlate that thing which is shown there. So in real life or some real life situation, sir, I'm not seeing probability at all. You won't see a probability. Right? Something is observed. So for example, in a production run, for example, in a Kia car, this thing that a new car, some SUV has come. What's that? Karens or Clarence or something like that. So what is the probability that there are defects in the production line or something like that? With what probability will be? So first hour about 10 cars are made. So what is the probability you find some defect? So you have attached a probability to it. We don't know like that. Probability will not immediately pop up and down. So there are 3 defects or something like that. It is with some probability. We don't know what caused that thing. That is, people on the shop floor will only know that what's the defect and all when they try to find the root cause for that kind of a thing. But as a quality control, there's a probability thing attached to it. So when I try to plot this thing, I plot it in a diagram. Anything. This is a discrete case. I've got only 4 values, 0, 1, 2, and 3. So I have to plot this thing. So what is the probability of these things? So if I plot it, 0 will have the first diagram there. So this is not a bar graph. Please remember this. This is a histogram. Histogram means like all bars will be one next to the other. If it is a bar graph, you have gap separating each one of them. So this is the distribution. So we have some things bars attached to it. So we have this sorted. So this is how we start our understanding with statistics. So this is how when we have this thing, we have a why do we have to study probabilities, because we have to connect the dot between statistics. So we had some maths and all, maths came up, probability came up and all. Then suddenly people say that what to do, we have data and all. So how to connect that gaps? So was this the way it came up? Who did it? As I told you, it was around early 1900s. Russian mathematician Andrei Kolmogorov was the first person who bought the frameworks. He wrote some rules and all, and everybody follows. This day, it is a practice worldwide. So toss of 2 dice. So what is the thing? Sum of 2 dice. So x is 2, 3, 4, 5, 6 and all. So what is 2? So 2 dice I have, 1 should come on thing. So what is the probability associated with it? It is 1 by 36. So if I have to get 3 between 2 dice, it is 1 by 2 and 1 and 2, 2 and 1 will come 2 by 36. So that's how we go on getting this numbers. So this is the probability histogram associated with things. So on the x-axis, I have all my x there. What is on my y-axis are the probabilities. So that is 1 divided by 36. Whatever is the number we get, we plot. For 2, that is the thing. And whatever we see on this diagram is the normal distribution. So this is where the things come up. So this is a bell-shaped curve. So it looks like a bell-shaped or a hat-shaped kind of thing. Right? Just seeing that. If you don't have anything like this in real life examples, we convert this thing to a normal distribution and try to solve a problem. So we not do probability. So we may have something like we are solving some problem with regard to stock market or something like that. So we go on mapping. So we do what is known as exploratory data analysis. With that thing, we have got collected lots of data, put every data side by side. They have got about 1,000 records. They have got about 10 different variables or random variables. We go on checking each variable because data preparation, data understanding and all requires up to 60 to 70% of the time. Modeling is easy. Interpretation even more, a bit time we spend. Modeling is easy, not a problem. Preparation is the where. So now we have to understand preparation, transformation, all those that requires time there. We have to really, we will not have answers for say about weeks together. We don't know like what to do. We don't have the data. Even today as I speak and all, I also face this thing. For sometimes like my associates, my managers who work under me not have any solutions. But we are in a very dicey situation. Client will be breathing down on our necks. We're not solved a problem. We don't know like. So we have to come up with some kind of what we do like. We make it a point to study the data clearly. Client may give a dump or something like that, or with permission of the client to get a dump of the data from here. There are databases and all. So we spend lot of time. We spend about 60 to 70% of the whole project on understanding the data. When we have understanding it, we move on. We know we have solved the problem. When I say 30 to 60 to 75, we know that already we have solved about 60 to 70% of the problem. We know that because that's by practice, like how data is there. So for example, you go to a doctor and all, probably for any, so today he prescribes many tests and all. You should have a blood test, you should have a urine test. God knows he'll write out everything because without knowing that he cannot do anything. So there might be experts like, so it's like 1 in a million, you might have somebody, a doctor and all, just by uh, seeing you, he might tell you that you have some kind of a problem and all. So without that test, it's not possible. Similar way, we also to try to do this analysis, do all this kind of graphing and all, come up with our plan for action next. So what is the probability distribution? Probability distribution can be used to describe the population. So it has a shape which is symmetric, skewed, mound shaped. Outliers it has which may fall under the curve or whatever we say, or we have unusual or unlikely measurements. It has a center and a split. So where we come to the aspect of a mean and a deviation there. A population mean is called a mu, and a population standard deviation is called a sigma. So when I plot a graph, for example, let me go back. So in this thing, the center of this thing is known as the mean. So from the mean, this thing, whatever it deviates, like, so this is some thing which has fallen here. So the last thing is like, from the mean, what's the distance it has deviated? The standard deviation. So for whatever data we have it, from A to Z of domains, whatever we have it, everywhere this is the same thing is used. So if X is a discrete random variable with probability distribution P of X, then the mean, variance, and standard deviation of X are given as like this. The formula, but Excel will allow us to do everything magic for us. We need not bother about it. So example, toss a fair coin 3 times, record X. Okay, that we have done it. We have probability of X, so X into P of X, X minus mu whole square into P of X if we try to do that. So mean of this distribution is 1.5. The variance is defined by this formula. So variance is 0.75. We are only interested in mean and standard deviation as I told you. Standard deviation is square root of variance. So this example, if my center this thing mean is 1.5, so the deviation from this 1.5 to the last thing is 0.688. So what is the distance? It is not centimeters, meters, inches or something like that. That's a distance in the Euclidean space. That's also how much it deviates from the center of the distribution. That is known as the standard deviation. I mean to say how if you have measurements of something, there might be irregular things which are not happening. For example, if a person is going for a heart checkup, if he finds if the doctor does a ECG or something like that, so he looks for the deviation. So he will also have a on this graphical this thing. He will also have a plot, like it will be wavering across that thing, that measurement. So we'll also have a mean. What differs mainly in that kind of a thing, that much he'll be interested. That's what he sees in that thing. So that is also principle based on mean and standard deviation. Of course, it is medical in nature. So 3 fair coins. What is the shape of this thing? Symmetric. It looks mound shaped. Outliers none. Center mu 1.5. That's what I told you now. Just now. As I told you, deviation from the center to the one block is 0. So this is how we understand it. This you always let it be you are handling transactions of millions, billions of transactions at all, the theory holds perfectly right. Henry Kolmogro's probability is perfect. So it's for the deviation of everything. So that also has been mapped for your understanding. So we learned this thing: experiment, sample space, mutually exclusive events, simple events, probabilities, relative frequency, properties of probabilities. Each probability lies between 0 and 1. Sum of all probabilities equals 1. The sum of probabilities for all simple events is A. We learned about counting rules, permutation, combinations. Event relations might have been a challenge. You might not have understood very quickly. You can ignore it, but yes, as you will practice and have a understanding of, I don't say immediately week or 10 days. It may take a year or two for you to understand event relations. No problem, not an issue. You can have a understanding slowly. So conditional probability, additive rule, multiplicative rule, law of total probability, base rule. So something cartoon here. Oh, we did that all, and 98% of it. Probabilistically, the person answers. Key concept of this. Well, this was all I had for probability. So I think I don't know, like if you say 98%, well, it's sure that yes, you have understood at least whatever I have put. Or at least I can expect that whatever probability you put for it, acceptable. Yes, any questions? Questions, anything you wish to know? Okay, I don't have questions. Hopefully, I understand that I have some knowledge, but please practice it. So let's move about solving this thing in our manual. So open the chapter 8 probability. We'll do this factorial, permutations, combinations, and all. Open your Excel, open this manual also. Try to do this. So we'll start by factorial. So if I want to find 9 factorial, I'll put it as equal to 9 factorial is 362,880. Any number you can put it, for example, it not be 9 itself. Of course, the same thing holds, like if you click on the formula bar effects, you can do all this again and again. So to evaluate number of permutations, 8p3. So I put permute 8, 3. So this is 336. The next, the combinations. So combinations of 15 and 12 is equal to 15, 12 is 4. So you can make this complex in terms of the formulas, functions, and all. You can bring all that mix and all, whatever you need to calculate. all these things can be done. So in silos, we are trying. So we did some this thing like x and p of x, like expected value I need to find out. So let's try to do this. So I have some. So we'll try to do v1 x and px. Let me try to put this thing. So So I have pasted like this. Do you know how to bring these things to different columns? Anybody has tried like anything like that?
You can do text to column, Professor.
Yeah.
Click on data.
Okay.
Then click on text to column. Under the data tools, you have text to column. Data tools. The fourth one. Text to column. And then select delimited. No, top. Select delimited. Then say next. And then select comma. And then select next. And then say finish. Yeah.
So this is the way which you. So these are all used for data preparation also. So this is the way which we try to do it. So I have bought the data here. So I have to find the expected value. So we had that E of x also. We just studied. So what we are trying to do is. So it's a raffle drawing. So I mean to say lottery ticket and all. I don't know. Probably in Karnataka state we don't have lottery and all. Probably other states do have some lotteries and all. So I say raffle. Raffle means nothing but lottery. So lottery also is one kind. I don't say it's a gamble. Of course, the theory behind raffle, this thing and all is pure play probability. So about 25 years back, we have done something for one of a client in Las Vegas. So something we had worked on for one of those, I don't know what you call casinos. They used a statistical technique known as so we have used something like Markov chain montage, a probabilistic. So this theory was developed somewhere in 1945, or I think, yeah, before the Second World War or something, by one guy, Robert Ulam. You can check for this his name in Wikipedia. So he was the person who did this. I keep referring to like when I was talking about random numbers and those, if you have a greenfield project about nuclear reactor or something like that, it was something related to. So this theory, whatever was done, first developed at that kind of defense, or I don't know what technology, or atomic energy or whatever it is. Same theory has been replicated to a casino. for quite some years. So I again remembered that. So this is one method. So it's a mix of probability, statistics, and all. That's the way which we have done. So it finds use and all. It is not one of the use. So it is about raffle drawing. Like we usually, as I remember, as my childhood days, I remember that like in the newspapers, we get this lottery draw and all. There were photographs, a young child coming to a box of numbers and all. So the child would pick up a number. So it is like mind is so there will be no bias or something like that. So I have seen photographs like that of a young child picking up something. And the child would pick up a number and all. So you would have a 8-digit or a 9-digit. It is the one of the lucky numbers. Like the price was 1 lakh. Say about 40 years back, if I have this very etched in my memory. It's a way of probabilistically try to draw that number. So it's not that one single number, when a last digit number or last two numbers and all would have some play. Last number would be a lottery ticket would cost 10 rupees at that point of time. So the last number, if somebody gets it, so he or she would get 100 rupees. So people used to get the number, they again used to buy 10 lottery tickets. So that's what people should do. I remember one of my own uncles was very much in lottery thing. He used to do this thing. I remember. So idea is like a probabilistic way of doing things. Scientifically true. Of course, it relates to more of gambling or people. So they banned it because people thought that they used to hard-earned savings were being put on this lottery money and all. So that went for a toss. Okay. Some bit of it, I don't know. People appreciate that or not, I'm not sure. So result of this calculation shows that on an average, one would lose 0.74 per ticket. So that's what is the idea which we have to come. So the outcome of a raffle draw and the corresponding probabilities. To calculate the expected value of winning from this example, click on an empty cell. So purposefully there is a negative thing and purposefully you got a negative answer. So result of this calculation shows that on an average one would lose some $0.74 per ticket. Purposefully it has been done that. So let's try to do that thing. So you also try to do things. So it should be on G. I don't know. I have B1 even to I don't know, I'm getting 497. It's telling you should get something else. So is there anything wrong in my class?
Professor, I think it said some product E1 to E1 and then B2 to comma B2 to E2, right? Like
Oh,
no, B1 is to E1, comma B2 is to E2. That I think that is what was written there.
okay, let us do that. So has you pressed Control Shift Enter as we need to do it, or it is just
Yeah.
enter? Okay, let me just press enter. Abracadabra, what is the magic? Yes. Yeah, thanks. So it is somebody loses on this. That is how we try to. Whenever we argue or something like that, this is one way. Like how to apply this. So the crisis example which I gave you and all, you might have some data like this. So how do you say that? You may say positively about that thing also, negatively also, neutral also. Take it in any direction. That is the way which you have to answer. So this was on about expected value. So next is about, we come to binomial probability. So distribution discrete has something like binomial, Poisson, and normal and all. So we'll try to do a binomial probability. So a 9% jury acts independently of the other members and makes correct decision with probability 0.65. We'll find probability that the majority, at least 5, will raise the correct decision. So Excel has an inbuilt function that allows binomial probabilities. From an empty cell, insert the function and then using arrow in the name box, list the offered function. So let us try to do it. So what are the information I have? So 9% jury, at least 5, 0.65. All these things has to be, you have to do it. Okay. So let's try to do that. On the screen, let me clear this. I can be on anything it will. Okay, I'll be here. On this thing, I click equal to binom dot. Yes, I have. So I need to get that thing. So what is happening? If I am not getting the thing, okay, no problem. Let's see.
You can click on that formula, Professor, which you can see down, right? It says number trials.
Oh, yes.
Yeah.
So, okay. So please you have to read the problem statement, how he has given, and try to put it. Exactly, you will have a dialog box open here. You have tried to put this in. Problem statement is important, and the information which you have to feed is very much there. So that we have to make sure of it. So he has put a number 4, that's fine. Trials 9, probability 0.65. So cumulative, he says that I have to have a cumulative value of 1 or something like that. The total has been put. Let's try to same example. I have a 4 here. I have a 9 here. I have a 0.65 here. So cumulative, it should total up to 1. True. So if I say this, what magic will happen? Yes, I get something. So the formula also will be like this. Please, this thing. You have to enter, for example, you get something like you directly put like this, you'll get an answer. Okay. I have got an answer of 0.17 or something like that. Yeah. What does it mean here? So we are calculating the cumulative probability Px less than or equal to 4. Okay. So what is the meaning that Excel calculation show that the probability of 4 or few jurors making the correct decision is 0.17. By subtracting this number from 1, we get 0.82. This is the probability that at least 5 of the jurors will make the correct decisions. So I have 9. Probability of x less than or equal to 0.17. Subtracting 1 from this thing will give you 0.8. So our answer should be for this thing. Find out at least 5 will reach the correct decision. So what is the probability number? So 82%, at least out of the 9, 5 people will get the correct jury. So 0.82 will be in the favor of whoever is standing for trial or something. If I put that number here, so is equal to 1 minus of 0. So this is an example from law. So there's a very book people can see on the web, that is for law. So you can do this. So this is how we do it. So how does one arrive like this? So what's the probability and all? Based on the past history, as I told you, there's some information which you have to provide. 0.65 number is something from experience somebody has given. Nobody can, based on the past cases and all. This is how, when I was trying to analyze this showing analysis. So your thought process. So somebody can put some other number also. So you have got other people. So somebody may not go with the 0.65. So if I have that kind of a thing, somebody based on his or her own calculation. So say for example, they put 0.45. So less than or equal to 4, that probability rises. 5 jurors are not able to come to a correct decision. Only 37% among them, or 37 probability, they will be sure for their vote towards whom they are voting or something like that. So that's how we have to interpret. That has to be very clear in mind. So this was a little bit of this thing. So any questions you have, please? So from the book, you can do a lot of things. So same thing, random variable, probability distribution, expected value. You can do a lot of examples here, how, why, and all. Please try this out. Yes, any questions? Anything you wish to know? Okay, so the gist, whatever we had learned in this thing, in our slide deck that has been demonstrated. Might be the examples are few, but please refer this thing. You can saw a lot of examples here. The way which I showed and our histogram of this thing, everything is here. One more, please refer to this thing. I have taken a very brief overview in this slide deck, even though that came to about 70 or 75 slides. So this is what I had with regard to probability. We'll move to statistics. So any questions, anything you have? Anybody? Okay. No question. So as I told you, for statistics, I'll be so this Adobe Digital Edition is some kind of pain in the neck. It doesn't work properly. When I scroll also, it doesn't work. So this is the thing. We'll be using this for our understanding. Hopefully everybody has purchased this thing, either a e-copy or a physical copy. So whatever I spoke and all regard to Excel is covered in this first chapter. Maybe lesser than whatever I have told, but as the needs of this professor, she has written it. So that's not a problem. So we'll follow this. Okay. So we do start with the random number generation. So as I moved from, as I told you, like we connected from maths to probability and just had a brief touch up with how could statistics be. We need to understand about random. We had done this, but more meaningfully we'll do with one example so that you also will understand like why we are doing this thing, what's the purpose of doing this thing. So all these things are very much needed as part of the statistics. Whatever we talk about random number generations is very much true for statistics. So while sampling from a population, we need random samples. This means each sample has a finite probability of being selected. So that's why I told you it is of some population. So if, I think I gave an example of 2 classes back, like that if I remember. So in a production, this thing, if I'm trying to find out how many defects are there or something like that. So I need not take all the products which are done in a one production day or something like that. I can sample it. Say for example, first 10 minutes or some every 2 hours, say about 10 products, something like that. So this is based on our experience. Like so on the shop floor attendant or the shop floor engineer or something like that will know about this thing to pick up the samples and all the process. So whatever the sample we try to pick up and try to come up with understanding, it is the random sample which I have to say. And this is a representative number for all the data or the produced goods in a particular day. We do this. A QA department, the actual manufacturing department, not worry, the QA department will try to take this. This is one of the many examples, right? Why we try to do a sample. So it is random number, a random sample. So here the random probability has a different meaning. It means that the set variable has a finite probability associated with it. What is the choice that I make the sample choice in a big production run in a day or something like that? It has some meaning attached to it. So we analyze it. It's not just somebody will pick up and do it kind of. So or we may also be not part of a manufacturing or something, but we have to ask the right question. I think that selected correctly or not. So that's why we try to do it. So now I showed a discrete thing understanding. So we do a random understanding and we generate what is the normal data. Normal data is some kind of a hat-shaped data. So this is built in Excel. We try to do something like that. So what you have to do? So we go to analysis tool, pick random number generation. So on your Excel thing, I go to data. So on the analyze section, I have data analysis and solver. So let's not bother. We have done solver already. Data analysis. Whatever is there completely, this is of statistics. So if you're able to see my screen, that's fine. Or please see this on your own screens. We have a random number generation there. And I click. So what are the components of this dialog box? We have a number of variables, number of random samples I require. So I talked about having a discrete, normal, or whatever it is. So in statistics, as part of academic exercise, like a discrete and a normal or whatever it is, and most of the thought process concentrates on the around normal distribution. So I want to have a normal curve or whatever it is, some kind of a normal thing will be selected. So let's try to do that thing. Going to the wrong window. So I try to generate the numbers, enter the number of variables. So let's see what are the things they have put it here. So 5 variables. Okay, let's go by that thing. 5, 3, normal. Yeah, 5 variables, 5 columns. Number of random samples, 3. So I want a normal distribution. That's fine. So automatically it will give a number of 0 and so every normal distribution will have a mean 0 and normal standard deviation. That means it's a standard normal variation. What we call. So I'll leave the random seed this thing blank. I will have an output. So I don't like the chosen F12 also choose output range. F. That is F12. Okay, I say okay. So ask for 3 things. Sorry, 5 variables and 3 records for that thing. So when I put this thing, so it generated me variable 1, variable 2, three numbers each. So this is record 1, record 2, record. So all the numbers are generated. So shapes, arrow, all are in this vertical format. I can generate. So this is the so I got 5 variables, 3 numbers. So this is how we generate. So never try to everybody have a random number generation. So every laptop, your laptop, my laptop, anybody else's laptop will have a random number chip built inside to the laptop. Generate randomly. So if somebody is working along with me. So what is the first number they are getting here? Same thing, 5181. When you see this, the author's numbers are minus 0.30023. The first one. My number is minus 0.5181. So anybody else, what is the number you are getting for this cell? Somebody answer? Yes, please. What is the number you are getting? Am I audible? Okay.
Professor, I got 0.49180.
Okay, no problem. Fine.
Yeah.
So that is one number we are getting here. So it is random. So your laptop, your random number generated, but the input are all same here. So it will generate a random number for you. So the author's textbook at the time when she did it, her number was something like this. So my number is something like this. So you got a number as 49. That's fine. So anybody else got, or you're understanding it what I'm telling when I say random number generation?
Professor, how do we apply this in our day-to-day work? Like, just trying to understand how do I relate it to.
That's what I told you. See, one example is like, see, when I create, see, if I don't have any data, for example. So I'm trying to, it's a greenfield project, for example. So
Okay.
greenfield means like you are standing in the middle of a field. You don't know, like, for example, solar panel and all in India came for power generation stuff. So we had experiences from other countries and all, but that is not India. What is similar to India, we may have an example or we may have an example. So at an X place, so what is the kind of electricity generation in a solar panel makes? So solar panel, like it is not something like a 10 by 10 panel or something like that. You have got fields of panel there. So I start with some one number like. So I have an experience, say for example, mostly it came from the West. So probably Germany is one of the examples they cite in the World Bank reports and all. So you start with some numbers like to input, like for example, I require for a panel a normal variable or something like that, or if it is some other variable which I have to take exponential, because this power generation means like, so as the day progresses, midday and all, my power generation was based on the solar rays or something like that. Some numbers will be there. So if it is a very bland kind of a thing and all, we may have to go to a lab or something like that where we have some numbers. But that's the second thing. So we have some numbers there based on the knowledge about that report or something like that, put a number to it, we generate a number. So we tell government of India, we tell or a private power producer or something like that, look boss, this is the kind of things which we may expect some your output. If you put one panel, you have got something. In a 1 acre of field, if you put about 100 panels, you get this kind of a power output. So this is an assumption through the base of the distribution knowledge we try to understand that.
Yes, Professor. One last question, right? So when we get negative values, what does that indicate? Like I can see in yours, there are negative values in the first row and the last row. How? So it means that, so if you're saying in your greenfield project, that means these are the places that you're not supposed to be using because the power generation will be less. Is that the understanding that we?
Yeah, that might all be like, see, for example, what angle you have to put. I don't know, like, let me say. Because, see, the angle which you try to put it, say, let me put it. See, you cannot, like, for example, a panel may look like this, right? I think you have seen some solar panels, right? So this is like based on the time. So sun sets in, sun rises in the east, sets in the west. So it should point out in the morning, it should point out there. So in the middle of the day, the panel should turn by itself like this. So because sunrise should hit like this directly. As it moves towards the evening and all, it should turn like this, right?
Correct.
So at that point of time, some things like, see, for example, so in the east or something like that. So Y negative kind of a thing, that's on a normal distribution assumption. I don't know, like in a solar panel kind of thing, what distributional assumption they make or something like that. So if you take a normal distinct assumption also, Y negative would be coming is something like, if I have to say, so the rays may fall something correctly here to this point. It may not be falling here at all. Okay. So we don't know like how the rays will come. Like so sunrise in Bangalore will be something in newspaper. It will say 6:03 a.m. or something like that. So 6:03 a.m. and all it might be hitting the only this panel. So it might be kind of negative in nature. That's why I get indication. Does that answer your question?
Yes, Professor.
Yeah, that is one thing. This is situation of generating numbers can be applied in wherever it is possible. In business also, you have a new product launch, for example. Say in India, Apple phone is coming out with something. So what is the kind of sales you can expect? So first time when it came, now probably Apple phones are available for quite some time now. So you have a history of something like that. But when you have a new product launch, like for example, I don't know, iPhone 15 or something is coming, what's the sales somebody can expect? So it is, you make an assumption like based on the past experience. So whether it's normal distribution, it's an exponential distribution, right? So I think it might be usually sales thing will be like this. So it's an exponential only. So it may start bland and it may move like this, and it will be hit a plateau. So you make with something. So I don't know what's the kind of price or what's the kind of sale. So the very first week of launch you may have 10 rupees. Second week or something like that, it may hit 50 rupees. They might be after 100 weeks or something like that, you may get 100 rupees. So 100 weeks afterwards, it may plateau like this. So 100 might go. So afterwards, what happens is sales drop. By that time, 100 weeks means like it might have cost about 2 or 3 years or something like that. So people will don't like that product. I mean to say, people will be looking for some more new things and all. So it depends on something. So this expectation of an this thing which is being modeled is something like we can do for random number generation. That answer your question.
Yes, Professor. So if I had to use the Excel to get the exponential data, like you said, we can use it for projecting what would be the sales first week, second week. Right now, what we did was we just gave saying there could be 5 different variables. And from that, we're trying to get 3 different samples saying that if these are the 5 variables that you have, then this is the expected results or outcomes from it.
Yes.
Right
So
now, when I know that I'm selling an iPhone and I'm planning to generate and I identify the future sales for it, how do we go about it? Like how, since you don't have any data, again, we cannot apply this logic, right? Because the
yeah,
number
we
is
cannot see. It's like analyst. Like probably you are analyzing something. You've been told by your manager. So you are about to make this kind of thing. So what are the so what are new features and all? So features of a phone is like some kind of a variables. So for example, in this iPhone 15 launch or something like that, they will say that 7 new features have been added. So, but in the sales of the iPhone 14 would be based on some features which is not there in 15. So you
correct.
have to generate some features. The features will be told by the what you call product group, saying that so these are the features which is being added or something. So for each of the features, what's the kind of numbers which try to model? So based on that thing, so they will say that the costing group and all will say that we like to price it at this kind of a number. So that is my Y response variable based on the new features added. So Y also some number they will say. So features also they will say that. So you vary the numbers of the features. So for example, say for example, you take a dipstick, like imagine that you are trying to contact about 1,000 customers. So you will ask them whether to saying that Apple, will not say Apple or something like that. Some new phone company is coming up with a smartphone with this kind of feature. Would you like it, or would you rate it from say 1 to 5 or something like that? So those numbers of 1 to 5 or something like that, instead of because going to a field collecting this thing, well, it might be challenge cost. So there might be bias, you not get the exact sample and all. Sitting in a computer lab, you can create a 1,000 into 5 matrix and some costing number because it is not pricing, please remember. So costing number they will give it. So if I have these features positively from such a person, you will hypothesize and say that the costing fellow would have given a number. So you would keep a price for that thing. So like we'll say that, for example, costing new phone will cost about 1 lakh or something like that. So you might ask the person. So one of a question to your audience would be like, what is the price you would be expecting? Because he or she would have paid about 80,000 already. They might say that, okay, I would like that it will, if it is for an 85,000 or something. So that number you will input in your Y. All the excess and all, you will try to put some values to it. That values of 1000 into 5 is being tried to be simulated using your Excel. So would that answer your question?
Yeah, Professor. So that basically means the X is the is a number of features, while Y becomes your
Pricing.
costing, pricing, and then you would select these two, and then again you would use the random.
No, I will generate the data using the random number generator with perfect distributional assumption. Then take it to regression analysis, project it saying, I come out with an equation, tell your sales manager something like that. So this is the kind of expectation. So what he will do is like, he will have just an equation. So equations we studied. We also studied like, if I put a number, I get a value for a Y. Okay. So based on a region, based on a time of say Diwali sale or something, iPhone 15 is coming to market or something like that. He will start be playing with, because he will talk to the distributors, to the retailers and all. Look, boss, this if you buy 1,000 boxes or something like that, so I'm going to give a discount, because at the end of the day, Apple would like to have money. They will not fail in anything. But this is the kind of preparation which you will be doing. Hope you understand the strategies of marketing or actual pure operations play here.
Yeah, Professor. Professor, is it okay if you can show that in the Excel, like how you would do it, like just to, so that the flow is like.
Yes.
Maybe it's like we're deviating, but I think
deviating, no. But yes, we can do it. I'll just show like what you can get it. Maybe you can generate and see the numbers. I think Deba, you had asked a question. Who is my convincing this thing good, or were you able to understand, or is there any challenges more?
I think I did not follow you how you started this, so just thought if you can redo this once more, that will help me.
Yes, let's try to do something. So,
I'm sorry, sir, I didn't follow. That's why I just request.
No, don't say sorry and all. It's my this thing. So let's see. Okay. So feature 1, feature 2, feature 3, 4, feature 5. So cost would be given. Some X. We have to put a price. So imagine this is a random number generated for Marnath, Shivaji. So imagine some number I have to get it. So here I have got the 5 features which I have to put it. So 4 numbers. So there are other people also. Not a problem. Let me for this. Where was I? Okay, go to data. Go to data analysis. Random number generation. Okay. Number of random numbers. Want 4. Let me put that as so this doesn't have many options. Okay, what can I put it? I don't know. Let me put pose on. Let me stick to normal itself. So my this thing would be F9 here. say okay. So if I went and contacted Amarnath, so I might not have physically contacted Amarnath. So this is for about 1,000 samples where I should have done a survey. I'm not going out or something like that, I'm not even using Survey Monkey or something like that. Based on my understanding of this thing, I was talking to my marketing team, while talking to my costing team or something like that. And of course, to the product team also, what were the 5 features and all. For 1,000 people, I'm trying to come up with some numbers. This is the thing which I come. So Amarnath has given this number to that feature. Amarnath has given this number to this thing. Deba has given feature number this one. Jinsi has given for F3 this thing. Purvi has given some number like this for a particular feature. So base, if I have this set of features and all, either that feature number will be like, it can be Amarnath's ask will be either x plus 1. So Deba might be x minus 2. T might be x plus 5. Purvi might be x minus 4. So if this data is ready with me through random number generation, so I have got correctly all the statistical properties covered here. Perfectly.
Professor, sorry to cut off. Under the price, we define it as x plus 1 or x minus 2. How is that we are deriving it at that? Like,
see, I don't know, as I told you, say for example, the costing likely based on all the input cost or something like that. So we are likely to price it at say about 100 rupees, he will say. So when asked to Amarnath, so this also can be put, some numbers can be put to this. So based on whatever, but it's 100 is the number. But what we do is like we put a business logic to this thing. If these are the kind of numbers, if you get it, so probably based on the cost of this what we call input cost as given by our product team. So I would put the Amarnath, the price would be 101. Put that. So Deba is 98. GC would be 105. X minus 4. So Survey will give a price of.
yeah, Professor. So I was just trying to understand, how did we say that I would say plus 5, or I would say minus 5 or minus 2? Like,
Yes. So
even
this this is the other thing. So we studied something about putting something in a mathematical form, right? So we have some kind of marketing base in terms of like we have a sales function, have some kind of market. So if we have this kind of, so what we do is like some kind of there's one more process, design of experiment. So where we seek that kind of analogy where if I have this kind of feature numbers or something like that, the price based on the input cost, I put a business rule. So business rule will tell me that if I have some certain numbers like this, the price is something for Amarnath. This is the, and the main due, these are all assumptions. Sitting in an AC room in front of our system, we are trying to modeling something using random number generation, having correct statistical distributional assumptions and all, and using business rules, I come up with this. So when I have this data and all ready with me, I take it to the next aspect of, so I name this as my variable. This becomes a variable now, x1, x2, x3, x4, x5. So this will be my Y. So I give my sales guy after modeling this thing. So this will be, as I told you, this will be a 1000 into 5 matrix. So my sales guy, how will we start negotiating with this distributors or retailers or something like that? He will have this equation ready for him. Y equal to function of 1 comma x2 comma x3 comma x4. So how will be this x1, x2, x3 and all? These numbers will be, for example, so equation regression kind of a thing. So it will be, so y will not be there. Y is the number which he has to get. So he'll have a constant be 1.2 plus the coefficients which are deriving minus 3.3 into x1 plus so on. So with the distributors and all, he will try to play with these numbers, something in numbers and all. The coefficients are derived using this matrix, so which has been generated to random number generation based on certain assumptions, and using a business rule, I have put the prices for this, and he comes up with this kind of equation. So sitting in, so for example, West, you might have a, I don't know, like what is the, who are the Apple distributors? I don't know. Reliance is one. I think there is something. It starts with A, right? Somebody distributor. Remember? So this thing. So he will start putting values for this thing. So what is the way which you will say, like so how many bucks? So he will get a Y for Reliance, Y for some other distributor, some B distributor. So I don't know what is this. So he will play with this kind of a. So that way you will have an understanding. So we'll say that, so 1000 Reliance wants about 1000 or 2000 box. A box will contains about 100 i15 phones or something. So like how it will be all like neatly packed and all. So we'll say that that is the thing. So what is the thing? So in all, if Reliance wants about 100 boxes of this thing, and I don't know, each will have about 25 or something like that. What's the price which he has to negotiate? So this will be some price he will have in mind based on the equation derived. So that will be confidence bands. So on an average, he will earn about based on the input cost, and because that has to cover marketing, so logistics, profit. So all the fancy CXOs will get fancy salaries and all. So the person who was modeled also will say that she is modeling this problem, so she will get an extra amount for this particular exercise or something like that, apart from regular salary. So all these things are done. So this equation matters. The business equation. So hope I was able to convince and give an answer which was applicable to everybody.
Yeah, Professor, kind of. Professor, this formula that you applied is nothing but y equals a plus b into x. Is that the one?
Perfect, right? Yes.
Okay, just one quick question. I know a is a constant, right?
Yes.
Like in this question that we had in the behind, I don't see that the constant or the variable or the exponential slope was provided. So then how did you get to 1.2 and 3.3?
That's the answer which I get through this.
Once you
Sure,
plot,
regression will come through this.
yeah, so once you plot it and is when you get it, is it?
No, need not plotting. Plotting is only to showcase that thing in a very easier way.
Okay.
You can plot it also. That also option is there, but the model is what which I want to get out.
Okay.
It's a whole process which goes about where these things is done. So we don't know, like I don't know the market, how it will be. See, what happens for iPhone 14 will not happen. Any product may fail also. This is only an assumptions which Jinsi has modeled. That's all.
Okay.
Not to say that if a product fails, Jinsi will be blamed or something. But there is always a Balika Bakra in the system, right?
Yes, Professor.
Yeah, Deba, was I able to convince you?
Yes, sir. Yes, sir. Absolutely. Thank you.
Yeah. So these are many ways, like really I can speak and all. So, but that's the way which I follow. So this is how. Okay, so I was only speaking to Deba, Jinsi, and all. How about others? So I'm not getting any response. Are you able to get a hang of it? Because all should be on the same stage. So, of course, it will take some time to digest these things and all. But what's the property of this thing? I should be able to convince. Yes, anybody has a question? Okay. Of course, quality control, there is an example. Please try it out. Very good example is there. You can do the way this thing. Please try this out. I think I have provided you data if I'm right or I'm not sure. You have to generate it. You have to generate it. You can generate it easily. So please do this exercise. Okay. So next we'll move to rank and percentile. Of course. So all of us, including me, have written all those all the examinations, CATE, I don't know, TETs in Karnataka. Today we have all fancy things, all IIT, JEE, NEET, so something like that. So we are all accustomed to what is a percentile and all. So the way the percentile is calculated basically by everybody, the GATE, GRE, SAT, IELTS, all are statistically based. Everything is done like that, but the interpretation and the cutoff or whatever fancy things and whatever business rules comes. So IIT, JEE, something like that. I think after decimal, so 3 zeros or 4 zeros also they consider. And they have a chance, for example, I think you have got unit test center, I think 4 different exam will be same, but you have got 4 different question papers and all. All those factors are considered to model that kind of a percentile. Calculation is same as we will right now see it, but the way interpretation is done for all these exams is the way which they tend to move forward. Of course, I think I have given you the data there. Please open it. So I have that CBSE score or something like that. It's about 7 records of data. So highest scorer in a competitive exam has, let us say, scored 98.42 and the second highest scorer is 97.59. For comparison purposes, percentiles are used. That's what is valid. So the highest scorer will be assigned 100 percentile and lower scorers percentiles will be calculated. The percentile score of the highest scorer will be 100 by 98.42 multiplied by 97.59, which is 99.16 percentile. How the calculations are done. Today CET, NEET, IIT, JEE, all those GATE, what fancy things also, all is done like that. But interpretation, the business rules, context, all differs. Want to filter and all, just change that after decimals you have 3 zeros, means change it to 4 zeros. All will be topsy-turvy. You might be very brilliant, I might be very brilliant, but we lose out on this percentile rank. So anybody has a good thing to say about this thing, or any bad experiences, or anybody in your family has encountered this? So they lost out a seat because of the percentile or something like that. Anybody here? I think there should be one or two experiences. Nobody.
This pandemic exam not happened, for that you are asking? Yeah,
Any entrance exam, so they will say that, for example, my brother didn't get it, sister didn't get it, my son did not get it, or somebody like second cousin did not get the chance because he lost out by some points. It can be anything. CBSE is some example I told to demonstrate like how this statistical method is done. So percentile is a statistical method.
This time actually the many people got passed now because of the 9, 10. They come so there is no seat for other people. They actually miss the seats because more pass out, and this is the year actually people suffered more.
Yes, absolutely right. That's a very good example. Yes. Anybody else? Any good bad experience? Love to hear that. I think many one of you, like for example,
Sir, when I completed my SSLC just through 1 percentile, I was not able to get the seat in this Vijaya campus.
Okay, very good. Yes, that's the thing. So that is percentile. Yes. So don't blame statistics, but the way it is done like this. So, okay. Yes. Anybody else? So before I moved into this kind of a roles and all, after my 12th, I also had appeared for the Indian naval this thing. So I also lost out on this thing personally. So
Sir, and in one more thing is that now also we see the sales, because we cannot just tell the numbers. So out of 100, how many percent of sales we have done for this particular month?
yes.
Or cash clearance, how many of that we have done? For that also we use this type for calculation.
Exactly right. Yes, yes. Fantastic. See, slowly you are learning the tricks of the trade. Good. Yes. Anybody else?
Actually, we would whenever the town hall gets happened, we would be in shock that how did they get this number? That Excel is so much. How did they get that percentage? When we are now seeing this, we are understanding how they got get the
numbers. That's what I always say. Please connect your business or job or whatever it is. Whatever job you are there, you can be sure. You may not use percentile, you may be using something else. Connect the dots, then only a subject becomes interesting. Always. So when I learned it also, I would say, oh, yeah, I'm learning all these things and all. But slowly, when I lost out, I found out that probably I had already lost out, because I said, why did you choose me? But I lost out like that. Very later in life, when I passed my masters, I came to know this was the cause. So, and after my 12th, like I had written the exam, I lost out on this thing because I was very keen to join the Indian Navy. I could not do it. Yeah. Anyway, so very good, bad experiences and are good. So what is behind this is statistics, percentile. We'll try to do. I have given you a data. So the data is in the zipped thing which I shared through WhatsApp. So data is 3.1. So please open that. So we'll try to do this thing. Okay. So we'll try to rank and have a percentile. So that is there here. Input range I have to select. So it is in the column, this thing. So what is my input range? Okay. So I select everything. So Excel can understand the column names also. Selected that also. So I go here. We're always going to that window itself wrong. Go to data analysis, rank and percentile. I say OK. Put range. Okay. Column, it is in the form of columns. Always make sure it's in columns. Row also can be done, but it's confused. Anytime practice also, please see that it's in columns when you're using Excel. So labels in the first row, perfectly right. So I click on this thing. It's labels in the first row. So output range. So what has the author taken? In the wrong way. P9. Okay. I also select like that. So let me select P1 should, and I say OK. So it gives an answer something like this. It has repeated, I'm not sure about it. Let's start also. No, let's start on C4 to C11. The thing the author also has taken. She has also selected the same thing, including and why it got repeated that much of time. Or is it correct? Sure.
Sir, can we do for multiple scores overall in the class, like if there are 35?
Oh, yes, why not?
Okay, that time we have to take by column wise, right?
Yes, column only you take it. Don't take it row wise.
Okay.
So I don't know. There's some challenge here. I'm not sure. Like the okay, what is there? So let me take this thing. Okay. The respective ranks and percentiles are found here. So point indicates the serial number in the original data. For example, 0.4 means like the fourth serial number 575. That is the first rank. So is 100 percentile. So that's how we calculate it. So this is the thing. So let me discount this stuff. So I'll have to map this. Go to home. So fourth is this fourth. 575 is this number. So he is the person with the first rank. So his percentile is 100%. That's how it is calculated. The set of numbers or something. People do this kind of a thing. So what matters of that 575? What people calculate? So triple IT JE in one center, you have got 4 different question papers. Who gets which floor has one question paper, which other floor has, even though it's a CBT, computer based test. So it matters there. So this is how we calculate it. So the ranking happens like this. So why everything is considered here? That's why the challenge is there. So we get this number. The first rank is this thing, that is the, this is also one of the statistics, calculating a percentile. So an example of recruitment drive or something is, you can try it out.
Yeah, aptitude
Yes.
or knowledge what the test in the office is like.
Yes.
CPT
Perfect.
training.
Yes, correct. So that is the one way of. So please try out. There are quite a bit of examples here. Only try it out. Okay, next we'll move to sampling. We'll do two types of sampling, random and systematic sampling. For this thing, I think close this. Don't save. Also don't save. I have 4.1. Okay. So I got two data sets. We'll try out one, other I'll leave it as an exercise. Please do. So we are trying to do a probability sampling now. So what happens if each sample in a study is assigned a finite probability of being selected? What if each sample has equal probability of being selected and is selected randomly? What if every n sample is selected? So now I think Punjab, Uttar Pradesh, Uttarakhand, or I don't know, Goa has gone for polls. I think yesterday TV channels, day before yesterday it completed. If I'm right. I think yesterday all the channels were reporting what's the kind of probably how many seats they will get it. So that's what they were discussion whole of the day. So even in the night also, I think I had a meeting. Probably I thought I'll have a class, but I could not. My meeting got over at about 9:30. So while having my dinner, I was seeing the TV. Projections were coming like so. To do that kind of a thing, they would not, because it's not a vote or a census kind of a thing. So they would have gone to a district. So what is the sample they will pick up for a particular constituency and try to say that these are the kind of numbers, these are the kind of seats a party like BJP, Congress, Shiromani Akali Dal, Samajwadi Party, Bahujan Samaj Party will. So for them, I think which was they have Axis one company trying to do, and they try to use this random sampling or systematic sampling or something like that. So that's the underlying theory which we are trying to see. So we'll try to answer that thing.
Sir, will even the audit sampling method also can be?
Yes, perfectly right. You are 100% yes. So audit is like Indian Audit and Account Services, especially from the, because I've been associated with government a lot. So your what you call the private audit companies also try. So you will have you not see all the records or line items or something like that for that thing. You have softwares, so everything is digitized. So they apply that software like you have to pick up certain records and all. So scientifically they try to pick up. Perfectly right. I'm very happy that you talked about audit. Yes. And like for example, people blame like Modi, like he's targeting opposition or something. It's not opposition or something like that. Even our income tax department is randomly trying to pick up people like this who are paying taxes, who are not shown their taxes. That's also through this thing. Of course, not my group. One more group in my company is working with some tax department where we are trying to do this thing for them. So we don't know who is the end person. We will not know his or her PAN numbers and all. We'll have some record numbers. Based on this thing, we're trying to predictive modeling and all. We're trying to identify those people based on certain features and all, who are the likely person they can go right. What is being done. One more example. Okay, we are trying now to see. Consider the population of customers served by a small electronic service company. So number of customers per day. So I have got a whole set of data. So details of number of customers served by the electronics company for 20 days. So do I have the example? Yes. Till 21 is there. First one is the row label here. So that is what I have put it here. So I have this thing. So if I copy this thing, so copy paste is not working here. Palette. Deva has helped. So we'll try. So select sampling from data analysis add-in, and we'll try to. So one of the foremost thing why sampling means is always connected to. Yeah, I should be here. So I should go to data analysis, sampling. So I have this dialog box open. So what are the things which I have to put in this thing is what we have to see. So input range. So B3 to B23. So B3 is it includes yes, table also. The number of samples which I require 5. Output range 1 more cell. So these are the 3 input things which I need to take it. Put to A1 to A21. Done. First row is a label. Done. Random samples I require 5. Output range. So I'll put it as T1. So abracadabra. So 25, 23, 23, 32, 24. Randomly are the samples which have been picked for me. So how do we interpret this? So this author gets something else here. 55, 54, 35, 55, 14 and all. So this is the samples which I have taken, which somebody needs to select for doing a further analysis. So 55 should refer to something here on the screen, 55 here, 54 here. So in my analysis also, I have this thing. So with 25, so this 25 and 25 color code. This one. So where is 23? Hopefully this is the 23. One more 23 is there here. I don't know. This 23 are randomly it has picked up from the slot and given me 5 random samples, which I probe further is what. So like in your audit example, so these are the 5 records. The auditor has to go further discover like what are the challenges there or something like that. So 23. So where is my 32? Yeah, 32. 24. Is 24. Yeah. selecting gray. These are the samples which I have to go up. So auditor will use a out of those much records or something like that, where you need to target for there are challenges and all. So randomly we pick it and give it to the auditor. So today things done through softwares or something like that. Everything is put it on data is stored electronically, so it's easy to. So this is a random way of selection. So if I have to do a systematic sample, so I will try to use periodic. So period is 4. So I'll try to put that thing and put some other. Here it was at E6. Okay, I'll put a different thing. The samples is also 5 is there, or it will not be singled out, I think. So let me put it here. Data analysis, sampling, okay. I put it to periodic. So this gets nullified. 4 thematic samples. Answer should be 1. Okay. So this is my systematic sample. Try to find out. So it starts at 34. Next it goes to 54. So what is done is here, output is obtained. Every 4th element is sample. 4th, 8th, 12th, 16th, and 20th are sample. So 4 means every 4th element is the sample is being selected. So first 4, next 4th, 1, 2, 3, 4. So let me put something here. So tick mark, card, symbol, a tick mark. Okay, close. Go to home, the center thing. Tick, insert, symbol, tick mark, insert, close, say enter. Home, grid center. So every 4 systematically. So 34, next is Control C, 54, next is 24, Control C, 24, next is 14, next is 46. So this is what it selects. This is known as a systematic sample. So every 4th sample is what I have to pick up. In quality control, every 4th hour you have to pick up the first unit which comes out as a fully finished product or something like that. So that is how way of demonstrating the systematic sample. So I got one more example given to you. Please do it, and there are many more exercises also. So this is that inspection exercise, production. Write out. What I had for today to cover. So for this, if you have any questions, I'd be happy to answer. Stop here. Tomorrow we'll continue. So we'll start with descriptive statistics.
Sir, all we need to do is just practice this.
Yes.
But sir, we need the recording. Still
The
pending.
challenge, Deba, I don't know what's happening. Even I get a sorry figure in front of you, all people.
Professor, do you have the recording with you? Because it's in,
I
it
have
will
to
be
put it, it's on the cloud.
Sir, we did not get it yet, sir.
I don't know, like Professor Rajan told, it will put on YouTube and share the link or something.
Yeah.
Yeah, he
I
told
We have
he'll
not got
be
our class
providing us
recordings
within
also,
2
sir.
days, but it is not yet given, sir, the link.
We haven't got our class recordings also.
Okay, I
Yeah,
think you
and the
should get
cloud
it.
also, we don't have the link to access the cloud, sir.
No. Cloud will be with the, that's a IT controls will have that thing. So where it will be because it has to get finished into some, then recording is ready, then it has to come. Process is there, so it will be a part of the university servers. Like it will be in a private cloud or something like that. Stored there. So you will get access, but it should have been given. I think there are other things like going on probably. I think Professor Rajan is there too. So please once more remind him. So that's what I can tell. So anything from my side, please feel
Yes,
free
sir.
to.
So we can go back to the classes which we are feeling, because while you are doing, if we do, we get that. Sometimes when we are trying all alone by ourselves, that time we face challenges.
1 minute, Mudala. Thanks, Professor. I'm logging off. Okay, sorry, Mudala.
Yeah.
Sorry. Actually, I have to join another meeting.
Yeah,
Sorry.
sure.
Thank you.
Please. So let me stop recording. So it says, are you sure you want to stop to the cloud? Yes. So it will be on the university cloud.